Hi, welcome, thank you for joining in into our first in a series of home learn webinar sessions. Each session is going to be split into a main presentation lasting around about 15 minutes and a Q&A session afterwards. We're planning to hold them every Wednesday at 10:30. The next one in our series being the new E145S control board. As I mentioned, there'll be a Q&A session after the main presentation. And we currently have 40 people watching. So depending on the number of questions that people post, we may not have enough time to answer them all live or here, but I will be posting a response to every single question that gets put on below and where you can type them in. So that you can log back in at a later stage and obviously look at read the response. Just so you know as well, in a few hours, this webinar is also going to be available as a replay. So you can come back and watch again just in case you've missed anything. Okay, so let's go straight into it. So I should bring the main presentation up on the screen. So what we're looking at is our solar panel kit, is what we're going to be looking at first. Essentially, the contents of the presentation are basically boils down to basic introduction, where it's aimed at, and obviously how we came about specification. We've also created a solar panel calculator, so we'll go through it and actually show you the actual Excel spreadsheet itself for you. And obviously the basic installation sequence, what comes in the kit, and a semi-simple picture as well. So you can see where it all looks up together, essentially. So where is this thing aimed at? We've aimed the solar panel kit at sites where there is infrequent use. We're usually looking at, say, 20 to 30 operations a day, and it's for where supplying mains power would not be cost effective. Simple examples of this are level crossings, where essentially, you've got, you need to provide a level crossing, but this mains power is 4 kilometers away. In that scenario, it's impractical to get mains power to it. The level crossing is used very infrequently because, like, in the middle of nowhere. The other scenario where we envision this being used is, say, a swing gate, like a five-bar field gate, or a sliding gate on a farm, on the entrance to it. Where again, it's it's 3 kilometers, 4 kilometers, something like that, to the nearest mains power tap. Again, it would not be cost effective for it. Where you're only going to be using a gate 5, 6, 10 times a day, something like that. The system where we're supplying is only to be used with 24-volt control boards. We don't have any suitability at the moment for any 230 or 240-volt applications. One of the project criteria of what we had is we wanted to be able to supply you a system where our calculator result gives you yes, and it'd be able to work anywhere inside the United Kingdom. We did it as a kit, so it's easier for installation for you and also much simpler for you to support for your customers. It's very easy to wire up and interface with our 24-volt control board range, as you'll see later. And we've also wanted to have a battery to allow continued operation in the absence of any sunlight for a total of 3 days. So that's where we started off with our basic project in order to create a solar panel kit. So first thing we did is one of my colleagues, Chris Ball, created a solar panel calculator, and inside it we basically includes a range of FAAC equipment where we know the standby current has been confirmed, because that is the key. It's the standby current that is actually the greatest killer on trying to use a solar powered type system. One of the future updates we're going to include, just so you know, is we're also going to include the EO24S. But as the consumption is lower than EO24, we expect just to be able to add a few more accessories at the same time. We've also created a solar panel calculator to add the option for you to add your own power consumption. So if the equipment that you want to fit on it is not listed, you can just put in down, combine in total the milliamp hours or the watt hours, or what's stated on the data sheet, and the calculator basically works out for you. Essentially, the specification, we started with 200 watts based on the kind of information we're getting from the solar panel calculator. as we think doing anything else is going to restrict the market applications really significantly, and also the number of accessories you're going to be able to attach to it and have them working all the time, which one of the greatest effects that could be is essentially on safety. The other way, if we increase the size significantly more, then we obviously start getting the solar panel sizes get much bigger quite quickly, which obviously means a greater wind exposure, and because of that, greater risk of it being knocked down or getting damaged. Based on the above, we spoke to our solar panel providers to help us select the right equipment. And one of the things that we found out from our supplier that obviously helped us to assist with our selection is that if we have 200 watts of solar panels in the darkest part of winter in the United Kingdom, as a general rule, the solar panel will only produce 200 watts of power in the entirety of the day. In the summertime, then essentially it will go way much more than that. We expect on average probably about 800 watts in June, July, August time of power production during the day from our solar panel system. But we wanted to size you a system that essentially works. When we say works, it's going to work any time of the year and anywhere inside the United Kingdom. Part of it we also went for is a 43 amp hour deep cycle batteries we use for it. Again, they, based on the information we had, they should be able to give us operate the system without a recharge for a minimum of 3 days, depending on what you've got attached to it. It might be much longer. It shouldn't be. It can't be any less than that based on the calculator. But depending on what attachments you have, it could be longer. Could be even as much as 6 days. So I've been talking about this solar panel calculator. This is a slide. You'll be able to. You can come back and have a look. But what I'll do is I'll actually show you the actual spreadsheet itself. So if you just bear with me just a second. So this is the solar panel calculator that you get when you obviously download it from the website. Now, first part is the system. Over here, we select what type of system you're going to be using. Say B680, B614, C720, C721. And we've used two SA100s with Eon 24. Essentially, that's the greatest load that the Eon 24 will ever experience, because all of these have been sized on, if you plugged in a radio receiver or whatever, and the maximum loading that the board can take on itself. So if we go for argument's sake, I'm going to select a B614, and I'm going to run some accessories. So if I use B614, and I want to use 2 pairs of photocells, and I want to use a exit loop, and I'm going to use also a keypad. Okay, so that tells me that will consume, if nothing else happens to it, 178 watts per day. And then we put in the number of cycles we expect to use. Let's say 50 cycles a day. Essentially, we still have a value of yes down here. So essentially, we can still use this equipment. If I go to, say, 60, still fine. 70, still fine. That's more than I expected. There you go. Around about 85 cycles. That's actually just 80 now. There you go, 80. That would have been fine. I mean, technically, I think it's 79 by the looks of it. I should have really checked this bit. You can see that the calculator is quite precise. But if you say you had a customer that wanted to do, let's say he wanted to do 200 cycles, I think that's a no. What we want to look at is what can we remove. So if we take off the loop detector, we automatically make this accessible. If I say we added a keypad back in, so it's keypad in, keypad out, still okay. We can still do that. You can see that you need to play around with what your attachments you've got to work out what's going to be suitable. Obviously, a B680 doesn't have the requirement to have a separate loop detector. So again, that'll be something you can play with. The other thing is you might have a requirement where something here isn't suitable. You'll always get a no. Let's say you're trying to run a maglock. It's not pretty much used about 350 milliamps. So you're running this system, but you're going to run a maglock as well, or using, let's say, that one. So essentially, that is completely unsuitable for our system if you want to have that many operations. What we can do is, if needs be, if I go back to my main screen, so just bear with me just a second. What we get, if you get a answer there's a no, obviously the first thing you should do is obviously reduce the number of accessories you have attached to it, or reduce the number of cycles, but that has a much smaller effect on the calculator than you'd expect. If essentially there is no, your particular customer is adamant that you must have solar power and there's no other way of getting mains power to the system, then the best thing you can do is get that information along with the completed form of the above as well, and specifying what exactly your requirements are. We'll essentially then get in touch with our suppliers and work out the requirements. Whereas we might be able to size you much larger solar panels and a much larger controller to be able to run your system. The other thing I will say is that we can supply you something that is larger if there is a immediate need for it. The only thing is we can't provide any type of mounting system for it. Nor can we provide any advice on how you'd mount it, other than basically saying it has to mount south and put it at roughly 30-degree, 70-degree angle, depending on what kind of where it is mounted. So there are limitations to what we can and can't do for anything that is a larger, what our spec system is. But essentially, what you're going to get in the kit, you're basically going to get everything that you basically see in that picture on the side. You get the two 100-watt solar panels. You get a charge controller for it. You get a pair of connectors, depending on how you connect the solar panels together. You get some battery cable. You get the two 12-volt batteries. You also get the steel cabinet enclosure. It will be pre-drilled with a vent fitted on the enclosure already. You also get a battery shelf, will also be supplied for you. And you'll also receive some cable glands, modulus connectors, and obviously the actual mounting kit itself for our solar panels, this kit, essentially. And along with the tubular support frame, you also get a set of instructions come with it. So you have an exploded view, basically showing how everything gets assembled together with itemized parts on it. And we'll also have some drawings on here, basically showing how tall everything is. The main galvanized steel post that we have that we supply for you is 4 meters tall. A meter of it will be buried into the ground, as you'll see shortly. Because essentially, first the wiring diagram. This is the wiring diagram you get supplied. It is quite relatively straightforward. You wire 2 solar panels in series together into the icon on the solar panel connections on the charge controller. The batteries get wired in series. We provide the battery link cable as well. And obviously the battery cable goes in with a fuse holder with a spade fuse on it. And then you basically wire out to the load. Now we will supply you the cables that link the solar panels to the charge controller, the cables that link the batteries to the charge controller. What we don't supply you is the cable that goes from the charge controller to the control board. The reason for being for this is essentially we don't know how long that is. You could have a very short run, you can have a very large run. What we recommend is no further than 35 meters away. But if it's within 15 meters, 2.5 mil core will suffice. Up to 25 meters, a 4 mil core instead, and up to the maximum, suggested maximum 35 meters, a 6 mil core. Anything else greater than that, essentially we suggest to get in contact with an electrician to determine the voltage drops and work out what you can and can't get away with on there. The other thing as well that we don't supply, but we do recommend, is a isolator switch. It's essentially just a way so that if your solar panel is, say, 20 meters away, you can locally isolate power from the system when you are doing your maintenance on the actual gate. So you don't want power still be coming in there, so you want to be able to easily isolate. What we supply you is the Molex connector at the other end. It's a plug, so it's two wires, 300 mil length, already pre-terminated into a Molex plug. This plug will be a direct connection into the C720, C721, or the B614. For a B680, then we need to use it needs to be ordered a separate plan number, which is 390080. We are looking to try and get rid of that so that we don't need to worry about ordering anything extra. It'll just be all in the kit. So hopefully I should have confirmation of that later today. One thing is for the E124 control board, we'll supply you some spades as well, will come in the kit. Because on the E124 control board, if anyone has ever looked, there is a direct connections for battery on the board itself. And it's positive and negative. Just remember to obviously observe the polarity on it. The only thing that is a worth of a note on the E124 control board is if, for any reason, you are using this as battery backup rather than as the solar powered version of itself, and you're going to have an E124 board powered up from the mains at the same time, then you must go into the you must use EasyBoard software, and you must disable the battery charging. Otherwise, the E124 board will be trying to charge back through the load connections the battery that it thinks has got attached to it. So you make sure you disable that part. Otherwise, it could cause damage to the charge controller, and unfortunately, that will be covered by the warranty. The other bit, so you'll see on the next slide, is an installation sequence for how obviously you're going to be installing this thing. I won't go into too full details. You can obviously have a look at this at your own leisure. But essentially, we want the installation site to be within 35 meters of the automation system. What we want you to is basically dig a hole that is 1 meter deep and a minimum of 0.5 meter round. And into that hole, you're basically going to put the steel mounting post and basically fill the hole you've created with concrete. And we'd also recommend pouring concrete into the pole itself at the top for additional strength. And obviously secure the pole upright while the concrete is curing. Once the concrete is cured, you can carry on and assemble the rest of the kit. I would generally suggest 2 people to install the actual frame up onto the pole once obviously the concrete's dried. Probably again the use of a mobile scaffold tower or something else suitable, down to your own risk assessment to decide that part. And one of the other things I had a thought of the other day is obviously if you are going to be mounting this in very exposed, windy locations, potentially you should consider adding like arrest cables onto the solar panel, the main steel post, just to give it even more strength that you already have with the big concrete base it's going to have onto it. And lastly, as we finish off the actual presentation, there's some pictures, obviously, of the essentially the kit with the door open on there. And you can see the batteries and where the charge controller basically fitted. Inside the cabinet on the picture on the right hand, on the left, sorry, you can see that there's a little nub sticking out. That's the vent cabinet. We sited the batteries on a shelf inside. The cabinet basically allows some space for you to put your cables underneath, coming in from underneath of the cable glands to have space and to add a little bit of extra ventilation onto the system. So hopefully you have enjoyed this presentation thus far, and we'll see what questions we have here for us. How many questions we got? Thank you, Dan. It's the first time. It's always the first one. Diameter of the pole is a 70 mil. Bear with me just 2 seconds. It's a 60 mil diameter pole. with a 4 or 5 mil wall thickness on it. Oh, Anthony, thank you. How long does it take to assemble the solar kit? Essentially, the first part of it is you're going to be mounting the pole into the ground. Obviously, that just depends on how long the concrete takes to cure. Once you've actually got the pole into the ground and the concrete secured, the next level is essentially assembling the actual kit. I would estimate roughly in the state of an hour to 2 hours to assemble the kit, and obviously the wiring, connecting everything up inside the actual boxes, and then wiring it back through to the actual system. So I would probably, if a customer allows themselves, say, an extra hour for it, sorry, not an extra hour, sorry, an extra day to have the solar panel kit basically fully assembled, then that should essentially be enough for it. Dan, how much is it? If I can't remember off the top of my head. If you send an inquiry in through to sales or to your regional sales manager, they'll be able to give you your confirmed pricing for it. And Ben, what warranty comes the solar panel and the batteries come with? Essentially the same warranty as we get from our suppliers, so it's a year's warranty. For it, we expect that the solar panels will and the batteries will outlive that significantly. Essentially, we can only provide the warranty that we get given to ourselves from our suppliers for it. But we don't expect. I think they expect the lifespan of these solar panels actually 10+ years, and the batteries depends on what's attached to it. Thomas, the batteries are 43 amp hour batteries, 12 volts. We wire them in series to get to 24 volts. Thank you, Anthony, for listing the solar price for it. The calculated max wind speed for the whole installation. I will need to double check my figures, so I'll see if I can post a response back from that. I would probably estimate in the region of about 25 to 30 miles an hour. It essentially is I wouldn't recommend putting it somewhere that's fully exposed without using some additional rest cables to give you more additional strength onto it. If you reset NEO 24, would that mess up the settings stop charging? No. It's only if you've defaulted a board that will probably be where the problem would be. But that's only if you are mains powering the system at the same time as as running it from the solar. Phil, is it possible to retrofit wind generator to up the charge rate and thus the number of operations? In theory, no reason why not. And the same thing again is we had a customer that had a very specific need, and there was no way of getting mains power where it was actually powering a maglock. So we have supplied to one of our customers a 550 watt solar panel system instead, so that you can run a maglock at the same time. So we can upsize those solar panels. The only thing we can't do is obviously do the fittings for it. Darren, right, will you supply any other mounting kits to a building? At the moment, we don't have a plan for it. But if we have enough inquiries, we can speak to our supplier. Essentially, I would expect there are ready-made systems available out there. We basically wanted to create a mounting kit that could be essentially standalone in of itself. And Darren, what weight are the panels? The panels, if I remember rightly, are about 10 or 15 kilos. Bear with me just 2 seconds. I'll try and see if I can quickly find out. They're not particularly heavy, these solar panels. I can quite comfortably lift one just by myself. So just bear with me just 2 seconds. I'll see if I can give you a rough idea. Okay. The solar panels are 7 kilos for you. Right. Are you using an MPPT charge controller? Don't know the answer to that off the top of my head. It's a charge controller size for the solar panels that we are using with the system. We can do either 12 or a 24-volt system on there. On that, we basically we took the advice from our suppliers. Don't know if this will give you what the answer. The controller uses a PWM, pulse width modulation technology. On there, I don't know if that actually answers your question on that bit. Oh, why a steel enclosure as opposed to GRP? I'll be honest, Andy. It's just we selected the steel. Just wanted to make sure the batteries are quite heavy themselves. Each of the battery weighs about 15 kilos. So we're going to have 15 kilos plus 15 kilos. So that's 30 kilos inside the actual housing itself. If I remember rightly, we were a little bit concerned as putting that much weight inside a cabinet housing, because obviously we're securing the cabinet housing with 2 brackets top and bottom at the rear. If you're mounting the cabinet to just the wall of a building or to something else, then you probably would be able to get away with a smaller plastic because you'd be able to give more fixings to it. But it's a bit limited the number of fixings we can supply and fit to the back of the steel cabinet. So we decided the steel cabinet is much stronger, so it's much easier to hold the batteries inside. Average lifespan of the batteries, I would expect they are in the range of the 3 to plus 5 years. Obviously, it depends on how the system gets used. That's essentially why we have to size it, go with the warranty of just um, a year. The only thing is obviously we don't actually expect to be using the batteries that often. The only time that the battery itself is actually really going to be used is on the nighttime, if you have nighttime operations on it. I'm just trying to see if it says anything on the expected lifespan. We'd expect the service life of the battery is roughly about 3 to 5 years, as mentioned, and could be able to last from 6 to 8 years older on there, if well treated. Right, Alpha, maximum amount of panels that can be connected to the system. In theory, there isn't. Actually, sorry. We need to operate the charge controller. So the charge controller that we have on there is sized for the solar panels we have attached to it. If you tell us that you're going to be putting more solar panels, or we supply you a system with larger solar panels, then the charge controller will be operated to suit the amount of solar panels you have on there. So, for example, like the system I said previously, where we supplied a 550-watt solar panel system, the charge controller was operated to match the solar panels attached to it as well. Because the current that can go free from the solar panel starts exceeding what the charge controller can handle. Is there any low battery warning notification? Out of the charge controller that we have fitted, The charge controller itself has, you'd have, obviously there's a display on it that basically tells us how much voltage there is inside the battery, the battery voltage level, how much charge is going into it, and how much load is coming out of it. But that particular charge controller doesn't have a low warning out of itself. In theory, the depending on what it's attached to, you might be able to get a low battery warning out of the device, but I'll have to investigate that a bit further for you. So hopefully, I think I've covered pretty much all of the questions there. So thank you for your time, and I look forward to seeing you all on the E145 S webinar next Wednesday, 100% again. As I said before, it should last about half an hour. We expect approximately 15 minutes for the main presentation and about 15 minutes for the Q&A session, which is what we've had here more or less. So hopefully this has been good for you, and I will see you all next week. Take care. Bye-bye.